Now in this question, what we note is degree of numerator is 3 and degree of denominator is also 3. So in such questions we can directly write x cube over x minus 1 into x minus 2 into x minus 3 is equal to coefficient of highest degree term in numerator, that is 1, over coefficient of highest degree term in denominator. It is x cube. Here we will get x cube. So coefficient of highest degree term will be 1 into 1 into 1. So this will be 1. Quotient of highest degree term in this bracket into this bracket into this bracket. It is a cubic. So we will get 1 plus partial fraction, that is a over x minus 1 plus b over x minus 2 plus c over x minus 3. And next step is we will multiply both sides by the denominator. What we will get is we will get x cube is equal to, now multiply by this, so this will be x minus 1 into x minus 2 into x minus 3 plus, now multiply this by the denominator. So x minus 1 will cancel with x minus 1 and we will get a into x minus 2 into x minus 3 plus b into, now x minus 2 will cancel with x minus 2, we will get x minus 1 into x minus 3. So x minus 1 into x minus 3 plus c into, now multiply this with this, what we get is x minus 3 will cancel and we will get x minus 1 into x minus 2, x minus 1 into x minus 2. So we get this identity. This is 2. Now to find these constants, we will put each linear factor equal to 0, 1 by 1. So first we put x minus 1 equal to 0, that is x equal to 1. So what we get is x is 1 and this will be 0, x minus 1 0, x minus 1 is 0. So we will get only this term. So this is equal to a into 1 minus 2, that is minus 1, 1 minus 3, that is minus 2. So this implies a is equal to 1 by 2. Now we put x minus 2 equal to 0, that is x is equal to 2. So 2 2s are 4, 2s are 8. So 8 is equal to, now x minus 2 is 0, this term will be 0, this will be 0, this will be 0, only this term will be left. So we will get b into x is 2, so 2 minus 1 is 1 and x equal to 2, 2 minus 3 is minus 1. So this implies b is equal to minus 8. This is minus 1, take this to the other side, we will get b equal to minus 8. Now we put x minus 3 equal to 0. That is x is equal to 3. So 3 3s are 9, 3s are 27. So this will be 27 is equal to, now x minus 3 is 0. Therefore this is 0, this is 0, this is 0. We will get only this term. C into 3 minus 1, 2, 3 minus 2 is 1. So we will get C into 2 into 1. So this implies C is equal to 27 by 2. So we have found all the three constants. Now we substitute in 1 and integrate it. Substituting A, B, C in 1 and integrate. Integration of this is this. Let this be I. So integration of this will be I. So I will be equal to integral. Now integration of this will be 1 dx plus a into integral of 1 over x minus 1. So a is 1 by 2 into integral of 1 over x minus 1 dx plus b is minus 8. So this will be minus 8 integral 1 over x minus 2 dx plus c over x minus 3. C is 27 by 2 plus 27 by 2 integral of 1 over x minus 3 dx. So this is equal to integration of this is x plus 1 by 2 integration of this will be log of x minus 1 minus 8 integration of this is log of x minus 2. So this is log of x minus 2 plus 27 by 2 into log of integration of this is log of x minus 3 plus c. So this is the answer. Now in questions where the denominator is the product of only linear vectors, all these vectors are linear. For such questions we have a shortcut. I will now discuss that shortcut. What we do is we will write x cube over x minus 1 into x minus 2 into x minus 3. This is equal to 1 plus x minus 1 plus x minus 2 plus x minus 3, and find these constants by direct substitution. The method is, what we will do is we will hide this x minus 1 in this term. Hide x minus 1 and put x minus 1 equal to 0, that is x equal to 1 in the rest of the term. Hide this and put x minus 1 equal to 0, that is x equal to 1. Put x equal to 1 in the rest of the term. For this we will put x minus 2 equal to 0, that is x equal to 2. Hide this and put x equal to 2 in the rest. For this we will hide x minus 3, so x minus 3 will be hidden and we will put x equal to 3 in the rest. And we will directly get these constants. We need not carry out this procedure. So for this, hide x minus 1 and put x equal to 1 in the rest. So this will be 1 cube, that is 1 over 1 minus 2 into 1 minus 3. For this, hide this and put x equal to 2 in the rest. So this is 2 cube over 2 minus 1 into 2 minus 3. And for this, we will hide x minus 3 and put x equal to 3 in the rest. So this will be 3 cube whole divided by, this will be 3 minus 1. And this will be 3 minus 2. 3 minus 2. So we get all these constants in a single step. So rule is, for this, hide x minus 1 and put x minus 1 equal to 0 in rest of the term. For this, we will hide x minus 2 and put x minus 2 equal to 0 in the rest of the term in rest. And for this, hide x minus 3 and put x minus 3 equal to 0 in the rest of the term. We will directly get these constants. So this is equal to 1 plus, this is x minus 1. Now this is 1, this is minus 1 minus 2. 1 over minus 1, 1 over minus 1 into minus 2. Plus 2 2s are 4, 2s are 8. 8 over 2 minus 1 is 1. This is 1. 2 minus 3 is minus 1. Whole divided by x minus 2. Plus 3 3s are 9, 3s are 27. So this will be 27 over. 3 minus 1 is 2, 3 minus 2 is 1. So this will be 2 over x minus 3. So what we get is 1 plus, this will be 1 by 2. 1 by 2 over x minus 1. Plus, this is minus 8 whole divided by x minus 2. And in this case, we have 27 by 2 whole divided by x minus 3, which is same as this 1 plus half x minus 1 minus 8 x minus 2 plus 27 by 2 x minus 3, which on integration gives I is equal to x plus 1 by 2 log of x minus 1 minus 8 log x minus 2, because this is same as this, plus 27 by 2 log of x minus 3 plus c. So this shortcut is available for questions where denominator is product of only linear factors. Then we have this shortcut. Now next is this. In this what we do is we multiply both numerator and denominator by cos x. So this will be cos of x whole divided by cos square x into 5 minus 4 sin x. Why we are doing this? Because cos square x can be changed into sin 1 minus sin square x, and then we will put sin x equal to t. Differentiation of sin is cos, so that is why I am multiplying this by cos. We will get cos x dx is dt, and rest of the question will change into new variable. When we put sin x equal to t, this will change to t, this will also change in terms of t, and this will go with cos x dx is dt. So that's why I am multiplying by cos x on numerator and denominator. So this is equal to integral cos x over. Now this can be written as 1 minus sin square x into 5 minus 4 sin x dx. We will put sin x equal to t. Then cos x dx is equal to dt. Therefore, this can be written as, let us denote this integral by I. So I will be equal to integral cos x dx is dt. This is dt whole divided by 1 minus t square into 5 minus 4 t, and this can be written as integral dt over 1 minus t into 1 plus t into 5 minus 4 t. Now we have to resolve this into partial fractions, and what we notice, the denominator is product of only linear factors. So we have a shortcut. So shortcut is available. And I can directly write this as integral 1 minus t plus 1 plus t plus 5 minus 4 t. These constants will be available directly. We can find these constants directly by applying the shortcut. What we do is 1 minus t. So hide 1 minus t and put this equal to 0. That is t equal to 1. So t equal to 1, numerator we have only 1. So this will be 1 over. Now t equal to 1. This will be 2. So 2 into t equal to 1. This will be 1. T equal to 1. This will become 2 and this will become 1. Now next is 1 plus t. Put 1 plus t equal to 0. Hide this and put 1 plus t equal to 0. That is t equal to minus 1. So hide this and put t equal to minus 1 in rest. So this will be minus minus plus. 1 plus 1 is 2. T equal to minus 1. Minus minus plus. So 5 plus 4 will be 9. We get the value of this constant. And next is 5 minus 4t. We will hide this and put this equal to 0 in rest. So this will be, when we put this equal to 0, we will get 5 by 4. T equal to 5 by 4. So we will get 1 over. This will be 1 minus 5 by 4. 1 minus 5 by 4. So this will be 4 minus 5 is minus 1 by 4. So we will get minus 1 by 4. And in this, when we put t equal to 5 by 4, we will get 1 plus 4. That is 9 by 4. So this will be 9 by 4. So this is equal to, now this constant is half. So we will have half integral 1 over 1 minus t dt plus 1 by 18 integral 1 over 1 plus t dt. And calculate this. We will have 4 4s are 16. 16 and this will be minus 9. So we will have minus 16 by 9. This will be minus 16 over 9 into integral of 1 over 5 minus 4t dt. So what we get is 1 by 2 log of 1 minus t. But here coefficient of t is not 1. It is minus 1. So we must divide this by minus 1. Whenever we use a formula for x for ax plus b, we must divide by a. Whenever a formula for x is used for ax plus b, we divide by a. So here a is minus 1. So we must divide by the coefficient of x, that is coefficient of t in this case. So this will be 1 by 18 log of 1 plus t. Here coefficient of t is 1. So we need not divide by 1. Minus 16 by 9 into log of 5 minus 4 t over minus 4. Coefficient of t is minus 4 in this case. So we must divide by minus 4 plus c. So this is equal to minus half log 1 minus t plus 1 by 18 log of 1 plus t minus. Now this will be minus minus plus, and this will cancel with this. We will have 4 by 9. 4 by 9 log of 5 minus 4t plus c. So this is the answer. Minus half log 1 minus t plus 1 by 18 log 1 plus t plus 4 by 9 log 5 minus 4t plus c. So this is how we use this single line rule. And in this question, one important point is we multiply numerator and denominator by cos x. Why we are doing this? Because if we multiply this by cos x, it will be cos square x, and cos square can be changed into sine. And when we will substitute sin x equal to t, this will change into t, and this will go in the simplification. Cos x dx will be dt. So this will be dt, and this will change in terms of t, which we can integrate. So it must come to your mind that we must multiply by cos x both numerator and denominator. Now next is this. We have x square plus 1 over x square plus 2 into 2x square plus 1. Now here we have x square plus 1 over x square plus 2 into 2x square plus 1. What we notice, we have only even powers of x in this. So at partial fraction stage, not at integration stage, but at partial fraction stage, I can write this as x plus 1, and this will be x plus 2 into 2x plus 1. Let x square be equal to x at partial fraction stage. You must keep this in mind. Now I will think this question as denominator is product of only linear factors, and I can easily reduce this to partial fraction. This will be equal to x plus 2 plus 2x plus 1. This will be capital X. Capital X plus 2, we can write this as x plus 2 plus 2x plus 1, and we will get the constants directly. Whenever denominator is product of only linear factors, we can apply the shortcut. So what we do is we will hide x plus 2 and put x plus 2 equal to 0. That is x equal to minus 2. So this will be minus 2 plus 1. Minus 2 plus 1 over. This we have hidden, and this will be minus 4 plus 1. This will be minus 4 plus 1. And in this case, we will hide this and put this equal to 0. That is capital X equal to minus half. So capital X will be minus half. So this will be minus half plus 1. Whole divided by hide this and put x equal to minus half in rest. So this will be minus half plus 2. So we can write this as this will be minus 1 and this will be minus 3. Minus 1 by minus 3 is 1 by 3. 1 by 3 into x plus 2. Plus. Now this will be half. This will be half and this will be 3 by 2. 2 2s are 4. 4 minus 1. 3 by 2. This is half and this is 3 by 2. So denominator on both these will cancel. This will be 1 by 2 over 3 by 2. So this is equal to 1 by 3. 1 by 3 whole divided by 2x plus 1. Now at partial fraction stage we will replace x by x square. This is important. We are doing all these manipulations at partial fraction stage, not at the integration stage. So this will be 1 by 3 over x is x square. So this is x square plus 2 plus 1 by 3 over 2x square plus 1. And therefore I is equal to, now we will put the value of this in this. So we will get 1 by 3 integral of 1 over x square plus 2 dx plus 1 by 3 into integral of 1 upon 2x square plus 1 dx. Now integration of both these is known. These are in the form x square plus a square, and integration will be 1 by a tan inverse x by a. That's why we replaced x square by x and reduced them to partial fraction, because we know the integration of this and this. Integration of this and this will be known. So what we get is 1 by 3 into, we can write this as 1 over x square plus root 2 whole square dx, plus we will take 2 common, so this will be 1 by 6. 1 by 6 integral 1 upon, this will be x square plus this will be 1 by 2. If we take 2 common, it will be x square plus 1 by 2, and 1 by 2 can be written as 1 by root 2 whole square dx, and this is equal to 1 by 3 into 1 by a is root 2, 1 by a tan inverse x by a is root 2, plus 1 by 6 into 1 by a. 1 by a is 1 by root 2. 1 by a tan inverse x by a is 1 by root 2 plus c, and this can be written as 1 by 3 root 2 tan inverse x by root 2 plus this will be root 2 by 6, root 2 by 6 tan inverse, this will be root 2x plus c. So in this question we changed x square to x, and now it is very easy to resolve this into partial fractions. If you directly make the partial fractions of this, it will be lengthy and we will arrive at the same result. So instead of doing that, we will write x instead of x square plus 1 and resolve it using the shortcut, and integration of both these will be known. Now in this question, what we notice, we have x square plus 2 and 2x square plus 1, which is same as the denominator of the previous question. Only changes, we have x instead of x square plus 1. But here what we do is, we know differentiation of x square is 2x. If we put x square equal to 2, it will be 2x dx equal to dt. Therefore x dx will be dt. So in this question we will put x square equal to t at the stage of integration. In the previous question we wrote x square as capital X at the partial fraction stage. Here we are making the substitution at the integration stage, because we have x dx in the numerator. So this will be 2x dx is equal to dt. X dx is equal to half dt. You can see the previous question on the side sheet. You must understand when the substitution is being made at the partial fraction stage and when it is being made at the integration stage. Compare the two questions and have a clear-cut understanding. So this will be equal to I is equal to integral x dx. This will be half dt whole divided by, this will be t plus 2, and this will be 2t plus 1. This is half into. Now what we notice, again the denominator is product of only linear vectors, so we can apply the shortcut. This will be t plus 2 plus, this will be 2t plus 1. t plus 2. Put t plus 2 equal to 0. Hide this and put t plus 2 equal to 0. That is t equal to minus 2. So this will be 1 because half I have taken common. So this will be 1 over t equal to minus 2. So this will be minus 4 plus 1. Now hide this 2t plus 1 and put t equal to minus half. This equal to 0 means t equal to minus half. So half I have taken common, so t equal to minus half. This will be 1 over t equal to minus half. So this will be minus half plus 2. This into dt. So this is equal to 1 by 2 into. This is minus 3. So this will be minus 1 by 3 integral 1 over t plus 2 dt. I am separating these terms. And this will be 2 2s are 4, 4 minus 1 is 3. So this is 3 by 2. So we will have 2 by 3. So this is 2 by 3 into integral of 1 over 2t plus 1 dt. And this is equal to, now open this bracket, this will be minus 1 by 6 log of t plus 2 plus 1 by 3 into log of 2t plus 1. And since a formula for x is being used for ax plus b, we must divide by the quotient of x, that is 2 plus c. And this is equal to minus 1 by 6 log of t. How much is t? T is x square. So this is x square plus 2 plus. Now this 2 cancels with this. So we will have 1 by 6 log 2x square plus 1 plus c. So this is the answer. I have taken this question only to make you clear that when the substitution is to be made at the partial fraction stage and when it is to be made at the integration stage. Now in this question, what we see is we have cos x in the numerator. Now if I put sin x equal to t, differential of sin x is cos x. So we will have cos x dx equal to dt. So cos x dx will become dt and rest of the question will be easily convertible in terms of t. And we will get a rational function, which we can integrate by reducing it to partial fractions. So what we do is we put sin x equal to t. Differential of sin x is cos x dx is equal to dt. And therefore I becomes, I is equal to integral cos x dx is dt. This is dt whole divided by 1 minus t whole cube into 2 plus p. Now this is a rational function. We will reduce it into partial fractions. So 1 over 1 minus t whole cube into 2 plus t is equal to. Now this is a over, we have 1 minus t whole cube. So we will have 1 minus t plus b over 1 minus t whole square plus c over 1 minus t whole cube. We will increase the power of 1 minus t 1 by 1 plus d over 2 plus t. Now next step is multiply by the denominator on both sides. Multiply both sides by the denominator. We will have 1 is equal to, multiply by this. So 1 minus t will cancel. We will have a into 1 minus t whole square. 1 power will cancel. 2 plus t plus b into 1 minus t whole square will cancel and we will be left with only 1 power of 1 minus t into 2 plus t plus c 1 minus t whole cube will cancel and we will get c into 2 plus t plus d into 2 plus t will cancel and we will have 1 minus t whole cube. Let this be 1, this be 2 and this be 3. Now we have to find the constants a, b, c and d. So first is we will put each linear factor equal to 0 1 by 1. So first is put 1 minus t equal to 0. That is t is equal to 1. Now 1 minus t is 0, so this will be 0. This will be 0. This will be 0. Only this term will be left. So we will have 1 is equal to c into 2 plus 1 is 3. And this implies c is equal to 1 by 3. So c is 1 by 3. Now we will put 2 plus t. Other linear factor is 2 plus t. So we will put 2 plus t equal to 0. That is t is equal to minus 2. Now 2 plus t is 0. This will be 0. This will be 0. This will be 0. Only this term will be left. So we will have 1 is equal to. Now t is minus 2. So 1 minus minus plus 2. So we will have 3. 3 3s are 9, 3s are 27. So we will have d into 27. And this implies d is equal to 1 by 27. D is 1 by 27. Now we have still to find constants a and b. So what we do is compare highest degree term, that is. Now highest degree term in this equation is, this is quadratic, cubic. This is cubic, this is quadratic, this is linear, this is again cubic. So highest degree term will be t cube. Comparing highest degree term, that is t cube on both sides. So we will have coefficient of highest degree term here will be 0 and we will get coefficient of t cube in this term. So it will be a into coefficient of highest degree term in this bracket is minus 1 square into 1. We will not get t cube from this. From here we will get plus t into minus 1 to the power of 3. Minus 1 to the power of 3. So what we get is, this implies a minus d is equal to 0. And this implies a is equal to d. And d is equal to 1 by 27. So a will be 1 by 27. Now still one constant is left. So what we do is compare constant term on both sides. What we get is, on left hand side constant is 1. From here the constant will be obtained by multiplying the constant terms. So it will be 1 square into 2. So this will be a into 1 into 2. From here we will get plus b into constant term in this is 1 and constant term in this is 2 plus c into 2 plus d into 1 cube, that is 1. If suppose we have, instead of 1 minus t we have b into t, so constant term will be 0. So we will have no constant term from this bracket. If this is b, t, so constant term will be 0. Now we substitute a, b, c in this and obtain the remaining constant. 2b. 2b, this is 2b. 2b is equal to 1 minus a, 2a. 1 minus 2a minus 2c minus d. And this is equal to 1 minus a. A is 1 by 27. So this will be minus 2 by 27 minus 2c. This will be 2 by 3 minus d. D is 1 by 27. And this is equal to 27 is LCM. So we have 27 minus 2 minus 9 3s are 27. So this will be 18. 9 into 2 is 18. Minus 27 ones are 27. So we will have 1. And this is equal to 21. This is 20, 21. 27 minus 21 is 6. 6 by 27. Therefore, this is equal to 2 by 9. And therefore, B is equal to 1 by 9. B is 1 by 9. Now we substitute A, B, C, D in 2 and integrate. Substituting A, B, C, D in 2 and integrating. What we get is, on integrating this, we will have I. So I is equal to integral, now A. How much is A? A is 1 by 27. A is constant, we will take it out. 1 by 27 over 1 minus d dt. Plus B. How much is B? B is 1 by 9. So we will have 1 by 9 into integral of 1 over 1 minus t whole square dt. Plus C. How much is C? C is 1 by 3. So we have 1 by 3 integral 1 over 1 minus t whole cube dt. Plus D. D is 1 by 27. 1 by 27 integral 1 over 2 plus t dt. And this is equal to 1 by 27. Now integration of this is log of 1 minus t, and quotient of t is 1. So we must divide by minus 1. Plus 1 by 9 into 1 minus t to the power of minus 2 plus 1 over minus 2 plus 1 into quotient of t is minus 1. So we must divide by minus 1. Plus 1 by 3 into 1 minus t whole to the power of minus 3 plus 1 over minus 3 plus 1. And quotient of t is minus 1. So we must divide by minus 1. Plus 1 by 27 log of 2 plus t plus c. So this is equal to minus 1 by 27 log of 1 minus t plus, now this will be minus 1 plus, so this will be plus 1 by 9 into 1 minus t to the power of minus 1 plus, now this is minus 2, so plus 2 plus 6, so constant is plus 1 by 6 into, this is 1 minus t to the power of minus 2, so 1 over 1 minus t to the power of 2 plus 1 by 27 log of 2 plus t plus c, and this is equal to minus 1 by 27 into how much is t? T is sin x. So we put t equal to sin x. 1 minus sin x plus 1 by 9 into 1 minus t. T is sin x plus 1 by 6 into 1 minus sin x whole square. We are back substituting t. So t is sin x plus 1 by 27 log of 2 plus sin x plus c. So this is the answer. Now next question is integral tangent theta plus tangent cube theta over 1 plus tangent cube theta d theta. So we can write this as integral of tangent theta is common 1 plus tan square theta whole divided by 1 plus tan cube theta, and 1 plus tangent square theta is secant square theta. So this can be written as tangent theta into secant square theta whole divided by 1 plus tangent cube theta d theta. Now if I put tangent theta equal to t, then differential of tangent theta is secant square theta d theta. So secant square theta d theta will become dt, and the rest of the question will change into new variable t. So this substitution will most probably work. So we put tangent of theta equal to t. So differential of tangent is secant square theta d theta is equal to dt. Let us call this integral as I. Therefore I is equal to integral tangent of theta. Tangent of theta is t, and this is secant square theta d theta. This is dt whole divided by 1 plus t cube. Now this is a rational function, so we will reduce this into partial fractions. We can write t over 1 plus t cube is equal to, first step is factorize the denominator into simplest possible factors. So factors of this are 1 plus t. Factors of a cube plus b cube are a plus b into a square minus ab 1 into t plus b square, that is t square. 1 plus t into 1 minus t plus t square. And this can be written as partial fractions of this now are a over 1 plus t corresponding to linear, and corresponding to this quadratic we will have bt plus c 1 minus t plus t square. Now multiply this by the denominator. Multiply, call this as 1. Multiply 1 by 1 plus t into 1 minus t plus t square. So this will become t is equal to, now if I multiply this with this, then 1 plus t will cancel and we will get a into 1 minus t plus t square plus bt plus c whole into, now this will cancel and we will get 1 plus t. Now put each linear factor equal to 0 1 by 1. So there is only one linear factor, so we will put 1 plus t equal to 0. This implies t is equal to minus 1. And this will be 0. 1 plus t is 0, so this will be 0. We will have only term from this term. So only non-zero term will be this. So this is equal to minus 1 is equal to a into t is minus 1. 1 plus t plus 1. This is minus 1. So minus 1 is plus 1 plus 1 plus 1. And this is 0. So this implies a is equal to minus 1 by 3. Now we have to still find b and c. So we need two more equations. So what we do is we will equate the coefficients of highest degree term. Equate coefficients of highest degree term. That is highest degree term in this equation is t square. So on left hand side there is no term of t square. So coefficient is 0. Here it will be a plus, and from here we will again get one term of t square, and that will be b into t square. B into quotient of highest degree term in this is 1. So b into 1. This implies b is equal to minus a is equal to 1 by 3. So b is 1 by 3. Now we equate constant term in 2. So equating constant term. Constant term here will be 0 and constant term from this will be a plus bt. There will be no constant term involving b, and from this we will have constant term c. So c is equal to minus a is equal to 1 by 3. So a is minus 1 by 3, b is 1 by 3, and c is 1 by 3. We now substitute a, b, c in 1 and integrate both sides. Substituting a, b, c in 1 and integrating. So what we will get is integral t over 1 plus t cube dt is equal to a is minus 1 by 3. Minus 1 by 3 over a over 1 plus t. So this is 1 plus t. And b is 1 by 3 and c is 1 by 3. So we will have plus 1 by 3 t plus 1 by 3 whole divided by t square. I can write this as t square minus t plus 1. So this will be integral of this dt. This is equal to minus 1 by 3 integral 1 over 1 plus t dt plus 1 by 3 of integral of this. Now this is linear over quadratic. So we will write this linear in terms of differentiation of this quadratic. So let this integral be known as I1. So I1 is equal to integral t plus 1 over t square minus t plus 1. Now this is in linear over quadratic. So linear over quadratic, now differentiation of quadratic dq by dt is equal to differential of this is 2t minus 1. So I will write t plus 1 is equal to, I must involve differential of this quadratic, that is 2t minus 1. So multiply this by 2 and divide by 2. So this will be 2t plus 2. Multiply by 2 and divide by 2. So that coefficient of t is 2. Now we need minus 1. So what we do is 1 by 2 into 2t minus 1 plus 1 plus 2. So this is equal to 1 by 2 into 2t minus 1, and this is 3. So plus 3 by 2. So I1 is equal to integral half 2t minus 1 plus 3 by 2 whole divided by t square minus t plus 1 dt. And this is equal to 1 by 2 integral 2t minus 1 over t square minus t plus 1 dt plus 3 by 2 into integral of dt over t square minus t plus 1. And this is a complete integral. What we do is we write linear in terms of differentiation of this quadratic. Separate into two. First will be a complete integral and second can be done by completing the squares. This is the method. So this will be 1 by 2 log of t square minus t plus 1 plus 3 by 2 integral of. Now we will write this in terms of complete squares. So what we do is t square minus t plus 1 is equal to t square half the coefficient of x. Half the coefficient of t is minus half. So we will add minus half square and subtract minus half square plus 1. So this is equal to t minus half whole square. And this is 1 by 4. So 1 minus 1 by 4 is 4 minus 1, 3 by 4. So this can be written as root 3 by 2. 3 by 4 can be written as root 3 by 2 whole square. And therefore this term can be written as dt over t minus 1 by 2 whole square plus root 3 by 2 whole square. Root 3 by 2 whole square. So this is equal to 1 by 2 log of t square minus t plus 1 plus 3 by 2 and integration of this. This is dx over x square plus a square. So integration is 1 by a tan inverse x by a. So this will be 1 by a. 1 by a will be 2 by root 3. This will be 2 by root 3. 1 by a tan inverse a. A is t minus half. T minus half over root 3 by 2. And this is equal to 1 by 2 log t square minus t plus 1. And 2 cancels, root 3 cancels, plus root 3 tan inverse. This will be 2t minus 1 by 2. This 2 and this 2 will cancel. We will get 2t minus 1 over root 3. So this is the integration of I1. This is the integration of I1. And integration of this is minus 1 by 3 log of 1 plus t. Now we substitute this in, say this equation as 3. So what we get is, substituting in 3. What we get is I is equal to integral t over 1 plus t cube dt is equal to minus 1 by 3. You can see the last sheet as a side sheet. So this will be minus 1 by 3, and integral of 1 over 1 plus t will be log of 1 plus t plus 1 by 3 into integral of I1. I1 is 1 by 2 log of t square minus t plus 1 plus root 3 tan inverse 2t minus 1 by root 3. And this is equal to minus 1 by 3 log of 1 plus, and t is tangent of theta. This is tangent theta plus 1 by 6, open this bracket, 1 by 6 log of t square. T square is tangent square theta minus tangent of theta plus 1. And on opening this bracket, we will have plus root 3 by 3. Root 3 by 3 tan inverse 2t, 2 tangent theta minus 1 over root 3 plus c. So this will be the answer. I will revise this question very quickly. So first is, we are given I is equal to this much. So when I take tangent theta common, we have tangent theta into 1 plus tan square theta, and this is secant square theta. From here we get the idea that we should substitute tangent theta equal to t, because its differentiation is occurring here. So this will be secant square theta d theta. This will become dt, and rest of the question is expressible in terms of the new variable, and we get t dt over 1 plus t cube. Now this is a rational function, so we must resolve this into partial fractions. So first step is factorize the denominator into simplest possible factors. These are the simplest possible factors. Now resolve this into partial factors. A over 1 plus t plus, this is a quadratic, so we will have bt plus c over this quadratic. Multiply by the denominator, we get this equation. Now put each linear factor equal to 0. So there is only one linear factor, so we will put 1 plus t equal to 0, and we get one constant. Now still two constants are left. So one of the constants we will get by equating the quotient of highest degree term. Quotient of highest degree term in this is t square. So here quotient of t square is 0. Here we will have a into t square. So a. And here we will have bt square. So quotient of highest degree term is b. Therefore we have b equal to minus a equal to 1 by 3. And then equating constant terms. Now constant terms in 2. Constant term here is 0. Here it is a, and from c. So a plus c is 0, and we get the values of a, b and c. Now we substitute a, b, c in this equation. So a is minus 1 by 3, b is 1 by 3, and c is 1 by 3. Now we separate these two. This will be minus 1 by 3 integral 1 over 1 plus t dt. Integration of this is log of 1 plus t. And this is in the form linear over quadratic. This is linear over quadratic. So we must express this linear in terms of differentiation of the quadratic. dq by dt is this much. So we must express this in terms of 2t minus 1. So what we do is, first we multiply by 2 and divide by 2. So we get 2t plus 2. Now we need minus 1. So write minus 1 plus 1 plus 2. So now differentiation has been involved in the linear. So this linear can be written as 1 by 2 into 2t minus 1 plus 3 by 2. Substitute in this, we get this. Now separate into 2. First will be a complete integral. This is complete integral, therefore log of t square minus t plus 1. And second can be evaluated by completing the squares. So here we are completing the squares. Now you can try these questions yourself on similar lines. You can try these questions on similar lines yourself. We are providing the answers.